This is the test review for Friday's test. It's going to start off with solving equations and inequalities, and there's going to be 25 questions, 25 points on this part. So we'll start off with number 1. What you have to do is draw a line on the equal sign to separate into two different parts. After you separate it, you put a multiply divide on top of the letter, the variable, and an add and subtract on top of the number value. Now then, the 25 is already subtracting, so I'm going to add 25. And the 3 is already multiplying, so I'm going to divide by a 3. So the first thing I do is add it to 25. And then I divide by a 3. And the final answer is x equals to 10. Now we're going to do the same thing for number 2, but number 2 does not have an equal sign. It has an inequality. So when I draw the line to separate it, I'm going to draw the inequality down here just so I don't forget about it. Again, the number by itself gets a plus or minus. The letter gets a multiply divide. The 23 is already adding, and the 5 is already multiplying. So I'm going to subtract the 23 and divide the 5. So I'm going to subtract the 23 first, and then divide by 5. And the final answer is x greater than 5. Now this is the part where either multiply and divide. Since we multiply and divide by a positive number, we keep this alone. If this was a negative number, we have to flip the inequality. Same thing here, draw a line. But before we can do the plus and minus, multiply and divide, we notice that there's an extra x. So we're going to combine like terms first. That right there says 6x take away 9x, which gives me negative 3x. So this and this becomes negative 3x. Take away 15 equals to 6. Now that we have the proper number, we can add and subtract, multiply and divide. It's already subtracting. It's already multiplying. So we're going to add 15 to both sides. That's the opposite operation. And then we're going to divide by negative 3. So x equals negative 7. Do the same thing here, but this is an inequality, so the end of the line, we always draw the inequality there. Just to remind us that this is an inequality, not an equal sign. Again, there's too many things happening right here, so I'm going to combine like terms first. This says negative 5x plus 2x. That will give me negative 3x. And then negative 8 plus 7 is also negative 1. Now we can do the plus and minus, multiply and divide thing. This is already subtracting, so we're going to add 1 to both sides. That's the opposite operation. And the negative 3 is multiplying, so we're going to divide by negative 3. The answer is negative 5. But since we divided by a negative number, we have to flip the inequality, so less than becomes greater than. In this case, again, we have to draw the line. We have a parenthesis, so we have to handle the parentheses first. In algebra, parentheses means multiplication. So we're going to multiply 2 times 3, that's 6x. And 2 times negative 7, not just 7, that's negative 14. Now we're back to the plus, minus, multiply, divide trick. It's already subtracting, it's already multiplying. So I'm going to add 14 to both sides. And divide by 6. Same thing on this side, but this side has an extra setup. Again, this is an inequality, so at the end of the line I'll draw the inequality so I don't forget that this is not an equal sign. Over here we have parentheses, and parentheses means multiplication. So 3 times negative 2 is negative 6, and 3 times negative 1 is negative 3. Remember, this is a negative 1. Now the problem we have is we have x on both sides. So an x over here and an x over here. And the only way to get rid of an x on both sides is to either add or subtract it out the way. Since this is opposite operation, the opposite of minus 3x is plus 3x. So we add it to both sides. This crosses out. And negative 6 plus 3 is negative 3x. Again, plus or minus, it's already subtracting. Multiply, divide, it's already multiplying. So I'm going to add a 3 to both sides. And divide by a negative 3. Again, if you multiply or divide by a negative number, you have to flip the inequality. So it becomes x is less than negative 8. For number 7 and 8, pretty much all we're dealing with is the fact that we have an x on both sides. So again, what you do is draw a line. And the only way to get rid of an x on both sides is to either add or subtract it out the way using opposite operations. Opposite of 5x is plus 5x. 3 plus 5 is 8x equals 18. Again, now we do the plus or minus multiply divide. Remember, the one with a letter gets a multiply and divide, and the one with the number by itself gets a plus or minus. That's a positive 2, so I'm going to subtract 2 from both sides. And that 8 is to the side of the x, which means it's multiplying already, so I'm going to divide by 8. On this side, I'm going to do the same thing again. Here's my line. I have 2 x's, and again, the only way to get rid of an x on both sides is either add or subtract it out the way. So I'm going to go ahead and do the opposite operation of a plus 3x. We can't add it, so we're going to subtract it. Subtract 3x from both sides. 5x take away 9 is less than 6. Again, remember, make sure you do this at the bottom so you don't forget. Plus or minus multiply divide. This is already subtracting 9, so I'm going to add 9. And again, the 5 is to the left of the x, which means it's multiplying. So I'm going to divide by 5. X is less than 3. Now, this is positive, so we'll leave that alone. Here we have to solve inequalities. Again, we draw the line. And we draw the inequality at the bottom, just so we don't forget it. The letter has a multiply divide, the number has a plus or minus. That 3 is already added, it's a positive 3, so we're going to subtract 3 from both sides. And then the 6 is multiplying, so we're going to divide by 6. So x is greater than 3. Now this is really important, this is positive, so we left it alone. If this was a negative, then we would have flipped the inequality. Now x is greater than 3 is not the same thing as x equals to 3. X equals to 3 means x is the value of 3. But if x is bigger than 3, then it gives me a whole lot of values because there's a lot of numbers greater than 3. So, to give me some values to make the statement true, the value of x that is bigger than 3, that could be 4, or 7, or 12. A whole lot of numbers bigger than 3. Give me 2 values that make the statement false. So I don't want x greater than 3, so I got to make it a number that makes this a false statement. So I'll put a smaller number here, like 2 is greater than 3. That's incorrect. 2 would make this a false statement. Or 0. 0 is greater than 3. No, that's a false statement. So whenever you have greater than or less than, make sure you remember that it's not 3. It's a number bigger than 3. X is bigger than 3 means the answer is a number bigger than 3. What happens when you divide or multiply by a negative number? Well, you flip the inequality. Alright, Christina goes to the market with $15. That means she only has $15. So it means she could buy less than 15, or she can use all of her $15. She buys one papaya for $2.50, and for each banana, she pays $1.50. Now, whenever you see the word per, each, and every in a linear equation, this is most likely where the x is going to go. So every time I see those 3 words, I just draw an x and see if it actually fits. So in this case, we know that she's paying $1.50 each banana, so that's $1.50x. And on top of that, she's buying one papaya for $2.50. And if she takes the money she spends on the bananas, and she takes the money that she spends on the papaya, we'll get her bill, which has to be smaller or equal to $15. Alright, so now that we have an inequality, we can go ahead and solve it. Again, at the end, make sure that you go ahead and draw the inequality for itself to make sure that you don't forget it later on. Plus or minus multiply divide. The one with the letter gets a multiply divide. The one with the number by itself is plus or minus. It's already adding. The $1.50 is already multiplying. So I'm going to subtract 2.5. And then I'm going to divide by 1.5. And that gives me 8.33. So $8, 8, and 33. So, how many bananas could she buy? She can buy 8 bananas and a third. Now, since we can't actually buy a third of a banana, we're just going to say that the answer has to be smaller or equal to 8. Okay? That means she can have 8 bananas, 7 bananas, 6 bananas, 5, 4, 3, 2, or 1. She can have any one of these amount of bananas. Okay, now we're going to go ahead and do little equations. Again, we're going to solve them the exact same way we just did the other ones. We draw a line on the equal sign. Since we're solving for Q, the Q gets the multiply divide. The R, anything else, gets a plus or minus. Since that 2R is already adding, we're going to subtract 2R from both sides. That leaves me with J minus 2R. Since J cannot subtract 2R, we just write them side by side, just like that. And on this side, we just have the Q. Now, there's no number next to it. There's no number dividing it or multiplying it, except 1. But when you divide by 1, it's the same thing. So we're done. There's nothing there to multiply or divide. You're finished. There's your answer. Let's try it again. We want to solve for H. So H gets a multiply or divide, and the other one gets a plus or minus. That 3Q is already positive. So what we're going to do right there is we're going to subtract 3Q from both sides. Alright, now these cross out. V minus 3Q is just V minus 3Q. Now, the H is right here. It's being multiplied by negative 2. So what I'm going to do is I'm going to do the opposite operation. And the opposite multiplying by negative 2 is dividing by negative 2. And that would leave the H by itself. And there you go. We just finished. Let's try it again. Draw a line on an equal sign. Find the letter you're solving for. Multiply and divide that guy. And add and subtract the other one. The plus 2x is already positive. So we're going to subtract. And remember, 10 cannot subtract 2x. You can't take a pencil and add it to a paper and get 2 pencils. They have to be the same kind. This is a number, this is a letter, a variable. So they can't add each other. So we go side by side. Now, that 3 right there is multiplying. So I'm going to divide by 3. And there's your answer. Another thing we could do is every time you have anything that looks like y equals 2x plus 10, we can actually go ahead and just plug into the calculator. The trick they're using here is they change the letter Y and X to the letter L and W. But we can still use the calculator if we want. Or we could just plug it back in. Well, I'm going to use the calculator. That's a lot easier. Turn it on. Y equals 2x plus 10. Go to the table by pressing second table. Now, they want the width is 50. This is the width. It's right on top of the x. So I want the x is 50. So I'm going to go all the way down until I get to x is 50. And my answer is 110. Another easy way to do it. Then they say the width is 50. I take 50 and put it right there where it says W. W stands for width. And then you can plug this one in the calculator. Get the same answer. Same thing. For domain and range, when I grow up, I want to be a doctor. So when they say the domain is 2, 4, 7, 10, that goes right here. And they say you have a y equal to, so we're going to go to the calculator and go to y equal to. Once we do that, what we're looking for is where x value is 2. So there's the x value, there's the 2, the number in front of it is 13. X value 4. That's 19. 7 is 28. 10 is 37. When I grow up, I want to be a doctor. So if I want to find the range, this is the range. These are the values of the range. So it's 7, 9, 13, 17. This will have a bracket in front of it and a bracket behind it. Alright, domain and range, and this one right here, what you're going to do is you're going to draw a box around the part that you are using. So you take a look at the line in the middle and draw a box to fit it in, directly where it's at. What that tells you is that you just need to concentrate just on that box. That means I didn't use this part. All this part is unused. I don't need that. All this part is unused. I don't need that. I only use this part that contains the line. So this is my x. If I want the domain, when I grow up, I want to be a doctor. The domain is x. Here's my x. It starts off here at 0 all the way to 8. I didn't use 9. I just stopped at 8. So we write it like this. Remember, domain is x. So you have to use x in the middle. Then we want to find the range. For the range, we're going to use y in the middle. The range is right here, the y-axis. Again, it starts off at 0. There's my box right there. And it stops right there at 16. We do the same thing right here. Now, the lines are not exactly perfect on this paper, but we're going to go ahead and stretch it out a little bit to make it perfect, to make this an easier concept. Again, all you're doing is putting the line inside this box. What does that mean? That means I didn't use any of this outside part. I don't need any of these numbers right here. Let's pretend they're not there at all. You're only concentrating on that box right there. For the domain, I'm looking at the x. The box goes to 1, 2, 3, negative 4. And 1, 2, 3, 4, 5. That's the domain. For the range, we're going to use the letter y. And that's right here. And the range goes to 1, 2, 3, 4. And negative 1, negative 2, negative 3, negative 4. Given the function g of x equals 5 plus 2x, what is the domain given the range? So when I grow up, I want to be a doctor. So whenever I see domain and range, I always try to make a table. This is the range. So these go right here. So I go to my calculator. Y equals 5 minus 2x. Go to the table, second table, 5 plus 2x. Alright, I'm looking for 1. Not this one, because the 1's on the right side, not the left side. I'm looking for it right there. So the one in front is negative 2. I'm looking for 9. That's next to 2. 13. That's next to 4. And 19. That's next to 7. So my answer is negative 2, 2, 4, and 7. In this case right here, we have 10 points of function notation. They ask for g of 7. They ask for g of negative 4. The trick is to write down the formula g of x equals to y. Then when they're asking for g of 7, really, they're just telling you that x is 7. So what I'm going to do is I'm going to look in the table and find out wherever x is 7. So I go to my calculator. Now look wherever x is 7. That's right there. The answer is 27. Again, we have g of negative 4. My goal is to always write down the formula g of x equals to y. So all they're saying is x is negative 4. So I'll go back to my graph, go to negative 4, and the number in front of it is under y is 5. Y equals to 5. Let's do it again. This one says f of x, that's the same thing as y, is 3, open parentheses, 2x plus 7. And you go to the table. And now I'm looking for f of x equals to y. Now notice, the 45 is on top of y. So I'm going to go look in the table, wherever I can find 45, under the y. There it is. It's wherever x equals to 4. What is the difference between g of 7 and g of x equals 7? G of 7 is telling me that x equals to 7. That's what it's saying. And g of x equals to 7 is telling me that y equals to 7. So depending where they put the number, right here, it changes whether it's in the y or in the x. On this test, you're going to be asked for a domain. And what they're going to do is they're going to use the same numbers, but they're going to put them in two different ways, and you got to pick which one to use and when to use it. This is pretty easy. This right here is discrete. You use it when the thing given is discrete. This one right here, use it when it's used as continuous. Whenever something is discrete, that means you count it. Like M&M's, I count M&M's. CDs, kids, toys, cell phones, things that you can count. 1 cell phone, 2 cell phone, 3 phone, whatever. For this one right here, use it when things are continuous. When things are continuous, you measure them. Like height, weight, time. So, if the word problem is mentioning something you can count, your answer needs to look like this. You notice it looks like you're counting 5, 6, 7, 8. You just list them out. But if the word problem is discussing something that you can only measure, then your answer should look like this. All right, good luck on the test.